So, hello everyone. So, welcome to last session of KubeCon. I hope it was a good experience for you. So, today we are going to talk about how you can just supercharge your AI ML observability. So, using OpenTelemetry and Fluent Bit. So, for the first half, we're just going to talk about practical strategies for monitoring AI ML workloads on Kubernetes environments. And at the end, I'm going to show you a pretty quick demo. So a little bit about me. So for the last 6 years, I'm just focusing on Kubernetes reliability and cloud infrastructure. So I'm working at Chronosphere. So Chronosphere is observability platform. So I'm just contributing that observes the platform. I am also open source contributor, so Fluent Bit CI/CD maintainer, and you can just see me on the Fluent Bit Slack channel. And my personal mission is like making invisible intelligence visible and actionable for everyone. So there are a couple of challenges with the Kubernetes. So, for example, ephemeral compute. So pods come and go quickly. They just basically take their logs and context with them. Resource orchestration. So there's a dynamic scheduling shift workloads across nodes constantly, and auto-scaling. So training and inference workloads just scale differently based on their patterns. And multi-tenancy. You can just deploy multiple ML models and share same infrastructure with different priorities. I think we already have a solution for them. So you can just persist your logs to some external log storage. You can just detect, for example, lemon nodes if you have issues with the nodes. You can just do predictive scaling. You can just forecast your traffic and just scale based on that earlier. Or you can do workload isolation. Those are the known issues. But there are some technical gaps with the AI ML application that I am going to mention more. So for example, unified telemetry collection. So collecting telemetry across heterogeneous components is really hard. And there's an issue with the Kubernetes-aware context propagation. So maintaining context as requests travel through the services, you have multiple services. And there are very different ML framework-specific instrumentation, so specialized monitoring for machine learning components. And you have to just connect your infrastructure metrics with the machine learning outcomes. So these gaps are basically create a blind spot in ML operations, and teams just struggling to troubleshoot model issues. So I'm just going to do a quick survey. So those are that I'm hearing most. So just please raise your hands. So do you have any issues with the model performance? With input tracking? So resource optimization? Okay. So cross-component tracing? Yeah, I think most voted for the resource optimization part. So we are just going to deep dive into monitoring complex intelligence systems. So what is invisible intelligence challenge? So you have a mission-critical AI system, right? Nowadays, we are just also powering our critical business operation, also relying some LLM application, either internally or externally. So we have observability gap. So our observability just monitor these systems, but they're just lags behind their complexity and impact. There's a control problem. So when system fails, part may be outside your control. So third-party components just basically creating a blind spot. So those are the 4 critical observability dimensions. So I'm just going to deep dive on each one. So model performance degradation. So you can see just silent decline. Models just decay in unpredictable patterns. And they just often fails without any explicit errors. There might be some concept drift, so real world data that just diverges from this training distribution, and gap just widens over time. There's a threshold creep, so performance metrics fluctuate with acceptable ranges, but just failures happen sometimes. You don't even just detect that. There's a prompt tracking challenge. So, for example, minor prompt variation just create different outputs. Small changes just cause big impacts. And also opaque relationship like prompt response connection remain invisible to traditional tools. And version chaos, so you're just constantly deploying new models. And also resource consumption patterns are different than the traditional ones. So you can just consume more resource for the same prompt with different values. And there are also complex deployment topologies like heterogeneous environments, your old Kubernetes cluster, not same. There are some third-party dependencies. There's some intricate service chains. There's some cross-boundary flow, so data crosses organizational lines. And why traditional monitoring just falls short? So what are we doing? We are just checking simple up and down signals, and this is just, you can just miss the gradual degradation if you're checking that. Or point-in-time metrics, so you can just capture distribution shift, but trains remain invisible. And also missing the semantic context, so if you're using APM tools, there's just lack of understanding model behavior. And there's also impact on the business side. So let's say you have a recommendation engine, and just gradual relevance decline leads to decrease click-through rates. And if your LLM hallucinating, there's just a possibility of incorrect responses. And you should also just, I think it was the most voted item, so you might just experience a cost explosion. So what is the path forward for the new observability? So distribution-aware metrics, semantic understanding, contextual correlation, and business alignment. So today I am here to just propose you or present you how you can do that technically. So my approach is Fluent Bit and OpenTelemetry together and combine solutions. So what is OpenTelemetry and what is Fluent Bit? So OpenTelemetry is open source observability framework. So it is vendor neutral. It just provides you vendor neutral collection. It is just first class Kubernetes integration and strong community integration adoption. Probably you heard a lot of OpenTelemetry during this conference. And Fluent Bit, it's just end-to-end observability pipeline. It's just lightweight if you're using on Kubernetes. It has some powerful transformation capabilities, and it has a seamless platform integration. So OpenTelemetry provides an open source standard for logs, metrics, and traces. So we're just going to talk about this standard. So it has a schema for logs, metrics, and traces. And it also provides transport layer. We are just calling it OTLP. And it has a very good instrumentation SDK. You can just auto-instrument some libraries, or you can just use the instrumentation SDK, and you can just expand your application using that. So we have a schema, we have a transport OTLP layer, and we have instrumentation SDK with the OpenTelemetry. So how Fluent Bit and OpenTelemetry works together? So basically, Fluent Bit collect transform, enrich, and deliver this data to your selected target. You can just consume logs, traces, metrics from OpenTelemetry and send it to OpenTelemetry via OTLP protocol. You can just consume multiple OTLP endpoints and send it to multiple OTLP endpoints. And let's say our application doesn't just give us a logs in OpenTelemetry schema. So we have, so basically Fluent Bit has OpenTelemetry envelope. So you can just send your log record, and Fluent Bit is just converting it to OpenTelemetry format. It is same for metrics. Let's say you have some Prometheus endpoints or StatsD or other metrics. Fluent Bit just convert it to OpenTelemetry compliance schema. And like I said, it has some sort of enrichment, filtering capabilities also. One of them, you're just consuming a lot of traces, and if you're just collecting the traces from LLM application, it's too chatty, so it just generates a lot of trace and spans. You can just use head sampling. What is head sampling? It's a probabilistic approach. It just take the head span and apply your filter top on it. If it applies, then send it to destination. Not, then drop the whole trace. And you can even do tail sampling. So it waits for all spans and check for all spans. If they apply the conditions, it passes. Not, it just drops. Let's say you have logs. You can just apply conditional filters. So for example, in this example, there's a conditions. You can just use conditional operators like and or. You can use comparison operators like equal or not equal or greater or less than. If your conditionals are good for the logs, so it can pass, not, then drops. And that was the presentation part, so I have a quick demo for you. Okay, I have a update. Okay, so this is just an EKS cluster. It has 2 GPU nodes on it. So I just deploy 2 LLM models on it. And I used something called KubeAI. It's a very cool project. I just recommend you to check also. You can just easily, those are my models. So it is Llama 8 billion instruct and Llama 8 billion Tulu. This gives me, using VLLM, it gives me OpenAI compliant endpoints, and I have a Python application running with these 2 models. I am just going to so this is basically Python application. It's just sending incoming chat requests to my LLM. That's it. I didn't use any metric or log or tracing in my code. It's just using the OpenTelemetry, OpenAI, open instrumentation, and just creating metrics, traces, and logs for all my applications. And it is sending it to Fluent Bit OTLP endpoint. I'm going to show you the Fluent Bit part. Okay. This is the Fluent Bit part. So I have OpenTelemetry input plugin configured. It just exposes OTLP endpoint for traces, logs, and metrics. You can just either send gRPC using gRPC, or you can just use protobuf over HTTP. And here we have output. It is just sending to my demo environment. So it is again OTLP endpoint. I'm just saying this is the metrics URI, this is the logs URI, and this is the traces URI, and I'm just giving my API token for my application, and that's it. And I'm also, as you can see, I'm just using the output as setDout. Let me also show you quickly. So at the moment, I'm just using some load testers. So these are the generated metrics, traces, and logs. Since this is so chatty, I'm just going to show you how it looks like on the UI. I'm just using Chronosphere platform, but it is another observability platform, so you can just use Grafana, Datadog, New Relic, Dynatrace, or any open source solution. But since I had an environment, I had used that. So those are the metrics part. As you can see, I just configured, I don't know, maybe 10 line of YAML. I didn't do any instrumentation. I just use OpenTelemetry auto instrumentation. And this is the result. It's just flowing on my environment. So this is the P99 client operation latency. As you can see, it just showed me the 2 models I deployed. This is the token usage. So these labels are just saying seconds, but it is just 950 tokens, so it is their tokens. Those are the metrics parts. Let's say I need the traces. It's also flowing here. So you can see your traces sent to your observability platform. And we have also generated logs here. You can just use ID to correlate them, and vice versa. Okay. Yep, that was everything I wanted to show you today. And if you have questions, I'm happy to answer, since I think we have a quite good time.